So in this lab here, we are going to be looking at the relationship between work and kinetic energy. So here we have Wally, an astronaut, I suppose. You can change his mass to whatever you want. And then you can exchange, he's got a fire extinguisher. I don't know if you guys have ever seen the movie Gravity. But one thing that it does a really good job of is it demonstrates the law of conservation of momentum very well, which we didn't have time to get into momentum this year because of this whole COVID-19 thing. But if you remember in that movie, she has to get around by shooting this fire extinguisher in the opposite direction that she wants to go. And so Wally wants to go this way, so she's got to shoot the particles in the fire extinguisher in the opposite direction. And in that way, it causes it to satisfy the law of conservation of momentum. But anyways, back to what we're talking about in law of conservation of energy. The fire extinguisher exerts a certain amount of force as it's being shot out, like that. And so when it's being shot out like that, it can it's going to cause him to accelerate when those forces are unbalanced. So I'll show you this like this. So notice Wally right now, the back of his backpack is a position of 0 meters. And so then when I shoot it, I can stop him whenever. But notice he's accelerating. And so there I stopped him a little bit before 35. And right here he passes a red line and then he passes another red line. Those are photo gates. In other words, it's telling how long it takes for him to pass between this point and this point. Now, what's interesting about this problem is this. While he's applying the force from 0 to this point right here, about 34 meters, it looks like, then that Wally's accelerating at that point. But from 34 all the way past 80, he's moving at a constant velocity. Because he's not picking up speed, his forces aren't unbalanced. And so therefore, when he passes through these photo gates that are 10 meters apart, he knows that he's traveling 813 milliseconds, which would be 0.813 seconds. So therefore, that is what we can use this to help us think about Wally.